Hello friends, welcome to our channel. In this video, we are going to simulate the speed control of PMSM by using hysteresis current control. So in the simulation model, there will be two loops. One is the outer loop and the second one is the inner loop. Outer loop happens to be a control loop controlled by PI control. Inner current loop is controlled by hysteresis controller. So let us see the simulation one. So this is the battery which will power the PMSM motor. The voltage of the battery is 300 volts, and here we are using an inverter with IGBT and diodes. And the output of inverter is connected to the three-phase PMSM motor. So this three-phase PMSM motor has a back EMF waveform in the shape of sine wave. The number of phases that we are using here is 3. And we are not using the preset model. So if you want to use preset model, you can very well select preset model and you can choose the motor that you want to have. And here we are giving the torque input. So the low torque input that we are giving here is 5 Newton meter. And to this inverter, we are supposed to give the gate pulses generated by this controller. And this controller gets the input from the previous stage. The previous will be the DQ to ABC frame conversion. Direct axis and quadrature axis current references will be converted to IB, IC and IB, IA, IB, IC currents, all the three-phase currents. And as you can see, here we have the speed. The speed reference is 750 RPM initially for 1 second, and after 1 second, the speed will be changed to 1500 RPM. Using this comparator, we are comparing the actual speed and the reference speed. This is the actual speed coming from the motor, and with this actual speed, we are comparing the reference speed. Here we have the error, and this error is given as input to the PI controller, and the output of PI controller happens to be the IQ reference, quadrature axis current reference. And here we have the ID reference. For this motor, we are giving ID reference as 0. So if you want to have field weakening method, or if you want to increase the speed performance, we can go for decreasing the reference. And here we have the rotor angle coming from here. The rotor angle is converted from mechanical angle to electrical angle and is fed to this block. And the output of this block will be 3. The first output is the IA reference, IB reference, and finally the IC reference. So with this reference currents, we are comparing the actual IA, IB, IC. After comparison, error is generated and the generated is given as input to the hysteresis controllers. Controller 1, controller 2 and controller 3. So the output of the first controller has to give the first leg switches. So the first one, this signal will be given to the first switch in the inverter, and this will be given to the second switch in the inverter. That will be present right below the first switch. Okay, so first leg will be taken from the hysteresis controller 1, and these are the pulses given to the second leg switches, and these are the pulses given to the third leg switches. So first leg and the second leg will have a phase difference of 120 degrees. If you see the phase difference between the first uh, of second leg and the first pulse of the third leg, the phase difference used to be 180 degrees. And if you see the phase difference between this and this, it will be 180 degrees. Okay, so the phase difference between different phases would be 120, and the phase angle between the upper half and the lower half of the same leg used to be 180 degrees. and we are expecting the sine wave from here, because after this conversion there will be a sine wave coming out of this. So we shall see it after running the simulation. This model is getting compiled as it is running. As you can see, we have the sine wave, and this is the reference sine wave based on the values of ID and IQ reference. And here we have the scope, which will give us the speed, actual speed, reference speed, and the torque. So we shall zoom this now. Is the yellow color line represents the reference speed, and the blue color one represents the actual speed. Yes, as you can see here, the actual speed is taking a while to reach the reference speed, and once it reaches the reference speed, it is settling perfectly. And here we have the low torque. So we have given a reference of 5 Newton meter. So as you can see, it is settling around 5 Newton meter. Still there is some noises, uh, but still it is settling perfectly at 5 Newton meter. So in the sense, our motor is perfectly producing a torque of 5 Newton meter. And here we have the current waveform. This is the first phase current waveform IA. This is second phase current waveform IB. And this is the third phase current waveform IC. 1 second, the waveform, the frequency of the waveform is less, and after that, the frequency of the waveform is high. This can be related with the frequency and the speed of the motor. Yes, the same model is available for download from the link given in the description. You will be directed to our website where you can purchase the model. Hope this video is useful to you. Please share and subscribe our channel. Thanks for watching.